Okay, good morning, afternoon, or evening, everyone. Welcome to the NASA Commercial Smallsat Data Acquisition Program Vendor Focus webinar for Maxar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we are going to go ahead and get started. What I'll do first is just begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat, and you should see that located on the right side of your screen. Excuse me. If you don't see it, you can click on the three dots at the bottom of your screen, and that will pull up your panels, and you can insert a check mark next to the Q&A panel. Today's webinar is being recorded. The recording will be posted to our NASA Earth Data YouTube channel within the CSDA program playlist within a week of completion, and then once completed, I will send an email to all registrants and participants that includes links to both the recording and presentation slide decks used within today's webinar. As far as timing is concerned, today's event will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Eastern. Excuse me. My apologies. During this afternoon's webinar, we will have one speaker from NASA CSDA program and 4 speakers from Maxar to present the vendor content. Dana Ostrenga is our first speaker for this afternoon's event. Dana is the CSDA project manager here at Goddard Space Flight Center. She will kick us off with an introduction to the CSDA mission and program goals, and also an overview of the CSDA IDIQ contract process. From there, she will provide a high-level overview of the CSDA program data holdings. After Dana has finished with her presentation, we will then transition to our Maxar speakers. Our 4 speakers from Maxar this afternoon are Andrew Canales. He's the Vice President of Strategic Partner Growth and Fed Civil. Let me go ahead and put this next slide up so you can see a picture of our speakers here. He will present an overview of Maxar and the company's current offerings available through NASA's CSDA program. From there, we will transition to Josh Siskind, who is a program manager for technology and innovation at Maxar. Josh will provide an overview of Maxar's 2D core imagery. Once finished, our third speaker, Ryan Hamilton, who is a precision 3D product manager, will present an overview for this product. Our final Maxar speaker during this afternoon's event is Dr. Francois Smith. Francois will discuss Maxar's analysis-ready data, and also atmospheric compensation, or ACOMP, and provide some research use cases. After our final speaker has finished with his presentation, we will transition directly into the Q&A session and the final optional polls. Before I toss it over to Dana, I just wanted to cover a few notes regarding the Q&A session. We will try to answer all questions within the time allotted, but if we are not able to address your question during this time period, our speakers will be able to follow up with you offline. With that, I am going to stop sharing my screen and toss it over to today's first speaker, Dana Ostrenga. So if you bear with me for a moment here. And let me pass the presenter role over to Dana. All right, Dana, you should have presenter role. And you should be able to go ahead and get started. All right, thanks so much, everybody.
Thank you, Jennifer. Can you see my first slide?
I sure can, thank you.
Great. So thanks for getting us started today. Welcome again, everyone, to the Commercial Smallsat Data Acquisition Program webinar series. Today, learning about Maxar. I'm Dana Ostrenga, the CSDA project manager located at NASA Goddard Space Flight Center. So if you missed any of our previous webinars, just to give you a little bit of background on the Commercial Smallsat Data Acquisition Program, or CSDA, Our program has the mission to focus on identifying, evaluating, and acquiring commercial satellite data that supports NASA's Earth science research and application goals. The program also has 5 main goals. 1, to establish a continuous and repeatable process to on-ramp new commercial data vendors, to enable sustained use of that data for broader dissemination to our scientific community, to ensure long-term data preservation, access, and distribution of that data, ensuring scientific reproducibility, and to collaborate and partner with interagency and international partners on the evaluation and scientific use of the data acquired. And then, of course, to comply with the 2003 U.S. commercial remote sensing policy. Our IDIQ on-ramp 1 is what is our contract vehicle currently in play, has been completed this year. So this was a multiple award on an indefinite delivery, indefinite quantity, fixed price contract in response to an RFP that closed March 25th, 2024. The contract goes through November 15th, 2028. So we have awarded 8 new vendors under the IDIQ on-ramp 1 process, which includes BlackSky, ISci, MDA, Pixel, Planet, Satellogic, Teledyne Brown, and the Tomorrow companies. These 8 new vendors join our previously awarded 7 vendors, which means we now have 15 vendors total on contract. For the new vendors to the CSDA program, we will evaluate their data, and once complete, they'll be able to propose to competitive task orders. If there are previous vendors that have held a blanket purchase agreement or BPA contract and have already been through the evaluation process, they can now compete under the IDIQ as well. We did receive proposed new products from 3 existing IDIQ vendors on this on-ramp 1 process, Maxar being one of them, enhancing the product suite available to the CSDA program. Maxar has been providing data to NASA programs before CSDA was even a pilot and before it got started. CSDA began migrating and archiving NASA's Maxar holdings into the cloud since 2020. We work really closely with our agency partner NGA in acquiring data under the next few and electro-optical commercial layer EULAs. Maxar has also been the first CSDA data holdings to be published to the Earth Data Search client, so it is now discoverable alongside other NASA Earth observation data. The Maxar data is available through the CSDA authorization process on our website. It's just a form that you need to fill out and answer a few questions, and you can get access. As I mentioned previously, Maxar is on the IDIQ contract and recently received a task order for those newly available products to the CSDA program, which are the Precision 3D data for the CSDA evaluation team to conduct an assessment. Currently within the NASA holdings available for access is the Maxar optical imagery. The products from the Worldview 1 through 4, GeoEye 1, QuickBird, and Econos, the surface reflectance on top of atmosphere products from October 1999 to the present, and also by request. Maxar will go through these products in more greater detail shortly. So on the CSDA website, we currently do have a listing of all of our data holdings, including the date range of the data that's available and where you can get access to the data. We also list any associated EULA with the data products, as some of them were acquired under different contract vehicles and have stipulations on the data usage. If you request data, I strongly encourage that you review the associated EULAs with the data that you access. We try to keep this updated, and we'll be revising this site in the future to make data information more robust so that you know specifics on each of these products and sensors. So once again, this all can be accessed through the CSDA website, and links are available in the slides that'll be made available after the webinar. So that brings us to the next portion of our webinar. Please welcome our invited speakers, Andrew Canales, Brian Hamilton, Josh Siskin, and Dr. Francois Smith. We'll be talking more in depth about Maxar. So I'll stop presenting, and Andrew, you can take it away.
All right. Well, thanks, Dana, and thanks to the CSDA team for the opportunity to share a little bit more about Maxar and to learn how we can best support this program. We want to hear from you, so please drop questions into the Q&A panel, as Jennifer mentioned. We've got a team of Maxar folks on the line ready to answer questions while we're speaking. So I'll cover a few slides just to help level set on who Maxar is, and then I'll turn it over to some of my colleagues to talk about some of the products from Maxar that are available through the CSDA program. So on the next slide, if you're not familiar with Maxar, we own and operate an industry-leading high-resolution EO constellation, and our imagery products serve multiple customers across multiple segments and multiple use cases. From earth science research, national security, mapping, navigation, energy, disaster relief, just to name a few. All right, so quick history lesson on the next slide. If you've been in the remote sensing field for the past decade or two, you're probably aware that Maxar started as Digital Globe. It was actually Earthwatch before then, but through a number of acquisitions, including GeoEye, SpadeAC, and Radiant, we became a much larger company. We were acquired by MDA at one point, and then we sold MDA but retained the EarthSat company, which has a very, very strong legacy in the remote sensing industry. And today we're privately held. So good history slide if there's any students out there looking for some history on the industry. All right, next slide. So Maxar helped start the commercial high-resolution imagery industry, and as a result, we have a few decades of expertise and a massive archive of data that's growing every day. We've got 125 petabytes in our archive available for our customers to tap into and understand how our planet is changing. We'll continue to shape the future of the industry. Much like many other companies, we're investing in AI/ML to try and maximize the value of information that resides in our pixels. We're expanding our constellation to include more high-resolution 30-centimeter imagery, and we'll continue to grow and expand our 2D and 3D product portfolios. So let's talk about our customers. So we work with a broad set of customers across the US and international governments, as well as commercial industry, and as a result, we have a very wide range of products that address an even broader set of use cases. So we provide 90% of the commercial GeoInt to our USG customers, serve dozens of international customers to help support multi-domain operations, national mapping, census, and environmental monitoring. And we also serve a number of different non-government customers, so enterprise customers. So if you've used mapping products like Apple Maps, Esri or Mapbox, you've probably seen our imagery. Strava is one of my favorite. So we do provide the foundational imagery layer to many of these products that are used by government and non-government users alike. So in addition to that, Maxar, as Dana mentioned, Maxar has been supporting earth science research for many years. These publications might be research that folks in the audience have authored. And as Dana mentioned, CSDA has access to 13 petabytes of Maxar data for NASA researchers to utilize. We want to hear more from you in the earth science community on how Maxar imagery is being used. So please reach out, let us know how we can best support. It helps us understand your work and how we can adjust and adapt and drive innovation within our product portfolio to meet your requirements. We'll have some names and email addresses at the end of the presentation, but Joe Carroll is our NASA account lead. Happy to take any questions after the webinar. Okay, so here is a slide on our constellation, starting all the way back with Iconos and QuickBird. As Dana mentioned, the data from those two satellites are available. Two satellites that really help shape the commercial high-resolution imagery industry as we know it. Sure, there's some Iconos and QuickBird users out there. Those two birds, along with WorldView 4, have been retired, of course, but our constellation, starting with WorldView 1, all the way to Legion 1 and 2, are actively acquiring millions of square kilometers per day, with resolutions ranging from 50 to 30 centimeter, and pan and multispectral bands ranging from 16 bands on WorldView 3 and 8 bands on WorldView 2 and Legion. All right, let's talk a little bit more about Legion. So we're really excited to share with the world our Legion constellation. We've launched 4 of the 6 Legions so far this year, expecting to launch the remaining 2 probably early next year. So Legion, what it will do for our customers is add capacity to areas of the world where there's very high demand and low supply of capacity. We'll triple our 30 centimeter capacity and overall capacity to about 6 million square kilometers a day. So that's double what we can offer today. And we'll also be able to revisit areas of the world much more frequently thanks to the mid-inclination orbit of Legions 3 through 6, which will create this dawn to dusk collection pattern. As many of you know, our satellites image between a 1030 and 130 sun angle, similar to Planet. So we're excited to see what types of use cases will be opened up by this dawn to dusk collection pattern. And then finally, we're gearing up for Legion 7 and 8. So those are our next two satellites. We always have to be working on the next satellites after we launch them. So stay tuned for more information on Legion 7 and 8. So let's talk about our product portfolio. So we segment our product portfolio into three different portfolios: information, access, and analytics. We'll focus on information today, and a brief summary of our Maxar geospatial platform and our access portfolio, but did want to give a quick plug to access and analytics. Access is really where our customers are reserving capacity on our satellite for dedicated tasking. And then our analytics portfolio is growing with change monitoring and products like Crow's Nest, which is a maritime domain awareness product where we leverage SAR and RF as a tip, and then Q with the high resolution electro-optical worldview constellation to detect and identify ships at sea. So my team members will go into a little bit more detail about our information products in the next part of the presentation, but I just wanted to highlight this. So within our 2D product portfolio, this is where our 50 to 30 centimeter resolution imagery resides. We also have 15 centimeter HD imagery. All the imagery is very accurate. That's one of Maxar's true strengths. Less than 5 meters CE90 positional accuracy, multispectral diversity, and then our base map suite, which is the product that you'll see in those consumer and enterprise GIS companies that I mentioned are our customers. Precision 3D, as Dana mentioned, this is new as of the on-ramp phase. So we're excited to work with NASA on this product, but this is where our DSM, DTM, mesh products reside. And then last but not least, we're excited to talk about our recently announced non-Earth imaging product. This is when we point our satellites away from Earth up into space and capture objects in LEO, MEO, and GEO. We actually captured an image of the NASA solar sail not too long ago, so we were excited to see that. All right. I won't talk too much about this slide because this is really the meat of the products that are available. So anything from starting from level 1B to level 2, level 3 orthorectified imagery, analysis ready data, vivid imagery based maps, CAVIS and SWIR, that's clouds, aerosol, vapor, ice, and snow, and then shortwave infrared, SWIR, and then of course our precision 3D data products. These can all be discovered through the CSDA program and offered by Maxar. So with that, let me hand it over to Josh Siskin to talk a little bit more about our 2D product portfolio.
Thanks, Andrew. And let me know in the chat if my audio is coming in okay or not. If we go to the next slide, I'll be talking about our core imagery and MGP, Maxar Geospatial platform. My name is Josh Siskin, and I'm a program manager on our technology and innovation team within Maxar's U.S. government organization. On the next slide, you'll see an image that may look very familiar to you if you've taken any class in GIS. And I do want to start first talking about our imagery base maps. They do provide the global foundation for a broad spectrum of geospatial workflows, and our vivid base maps, which I'll touch on in just a minute, provide the consistent global accuracy that's required for working with other data sets for mapping and feature extraction use cases. Using our advanced accuracy and co-registration techniques, these base maps assist all users in better understanding the world including using the myriad of geospatial data sets you see in that very familiar image there, including terrain, aligned vectors, and 3D maps. The next slide goes into our vivid base map, and starting with our standard base map. And hopefully you saw that transition happen, going from a very pixelated and patchwork base map to something you see here, which is the first commercially available online global base map with a consistent 30-centimeter resolution and 5-meter accuracy. Now, when we create our base maps, we begin with a careful selection of the most recent cloud-free images from our archive to create, again, this most current clear view of the ground as possible. We use our bundle block adjustment technology to improve the location accuracy of the source imagery, resulting in a higher accuracy base map. We remove topographic and sensor distortions from the imagery using our global digital elevation model and normalize image reflectance using our ACOMP, or atmospheric compensation algorithm, which I believe Francois will talk about here in a little bit. We also go further and match the radiometry of each image and use a proprietary seamline placement algorithm to create the uniform global base layer for visual consistency across large areas. Now, this vivid standard base map you see here, again, is a 30-centimeter resolution image with 5-meter accuracy, and this is actually over Tokyo, Japan. 40% of the images in this base map have a currency of at least 12 months, and 75% are within 36 months. Our standard base map is really a global one, as it covers most of the global landmass, over 135 million square kilometers. Now, our advanced base map on the next slide goes a little bit further, as we produce a high definition 15-centimeter base map that doesn't cover the globe, but right now we're up to 3 million square kilometers. The reason for this is we specifically look for areas of urban change and population, and we update this base map quarterly to incorporate recent imagery collections to really offer not only the most highly accurate, but also the most up-to-date coverage around the world. And the quick aside for me is I think everyone is jealous at us talking today, because I get to show all these really beautiful images that you can see here that sometimes to remind yourself we're collecting from space. Now, we have our vivid, standard, and advanced we talked about, but there's also our dynamic base maps as well. Now, our dynamic base maps provide you, the customer, the flexibility to request custom base maps, including the ability to define the area of interest, the age of the source imagery, and the mosaic parameters, including the resolution, accuracy, and spectral bands. Once that request comes in, we're able to make those dynamic base maps for you with only a few weeks or so. This is really an opportunity to create and define the base map that you need for your mission, as opposed to using what we may recommend in Vivid. Now, as Andrew alluded to, I'd like to talk a little bit more about specific image products. And if we go first to the next slide, again, an excuse to show off some really great looking imagery. This is from our WorldView 3 satellite. But our next slide here, we'll talk about those specific products as well. Now, for many of you here, working with satellite imagery may be second nature, but for others, it may be a little bit intimidating, especially for those that don't have the experience working with satellite imagery outside of a base map, or potentially for those that don't have the experience or access to processing pipelines. We have created multiple image products to make it easier to work with satellite imagery. First, we have our System Ready 1B, and that's designed for users that do have the advanced image processing capabilities, but need flexibility to perform their own processing to produce ortho-rectified imagery. This imagery is 5-meter resolution. It's not available in HD and does have, 5-meter accuracy, not available in HD, and does have a resolution between 30 and 80 centimeters in both panchromatic, natural color, and color infrared product options. Our ViewReady 2A product is ideal for users performing feature extraction, especially those using AI and ML workflows. Our OR2A is designed for those advanced geospatial professionals who want to integrate product into their geospatial data workflows and already have a DEM to work with. Now, that OR doesn't stand for ortho-rectified, rather it stands for ortho-ready. Our map-ready ortho includes the highest amount of post-processing being applied. And this image product is ideal for those users who need ready-to-go imagery that's available in our HD and is available in both 15, 30, and 50 centimeters. Lastly, if you'd like to create your own 3D products, we do have the system-ready and view-ready stereo imagery, which has an absolute geolocation accuracy of 10 meters, and you can then use it, as mentioned, to create your own 3D visualizations and products. Now, our high-definition imagery, as I've mentioned a few times, does increase our 30 centimeter to 15 centimeter, and it creates both higher image clarity and also now simulates what would be only available through aerial imagery, now making it easier for AI and ML workflows. Now, if we jump ahead, lastly, I want to touch very briefly on our MGP, our Maxar Geospatial platform. MGP, on the next slide, you'll see a quick screen grab of it, provides fast and easy access to Earth intelligence. It's available either through a web-based UI or through APIs, which gives subscribers access to over 3 million square kilometers of daily image collections of our 20-year, 125 petabyte image archive. Now, on the next slide, I have a very brief video that will kind of fly through what it's like to work with MGP. Now, as you can see, I'm going to go immediately to a location in Barcelona. And once I start panning and zooming around, you'll see on the left-hand side, the image carousel starts to populate with available images from our online imagery collection. I can easily turn them on and off and pan and zoom around. I can also turn the imagery off and actually turn on our vivid base map, which I'll do here. You can see the aesthetic and accurate base map that's available as I pan and zoom and actually take a look at some of the different ships here sitting in Barcelona. Now, as I'm panning around, I see a very unique location where it appears to be some pink or red features sitting on a green field. I'm going to pivot now to turn the imagery back on and go to our archive imagery. And I'm able to filter based on cloud cover and sensors. Now, I do see the question from Spencer. MGP is going to become the platform that Global EGD will run off of. As I've gone through and filtered, I'm able to choose that first image that has the right cloud cover and sensor selection that I chose. I can turn on some pre-processing, including AComp and HD. And then I can start to do some different band combinations, this one looking at vegetation. And from that, using this exploit mode directly in MGP, I'm actually able to see that that does turn pink amongst the red vegetation. And being a very novice remote sensing scientist, if I could even call myself that, I can start to determine that maybe that is some type of vegetation that's sitting on top of that green field. You can see the entire image is going to have applied that preset of vegetation, and then I can start to apply different ones there as well, including going to the panchromatic view. At this point, I think I'm ready to order the image, and so I'm going to close out of exploit mode and very simply select on that menu option to order the image. And as you'll see here, we have different options to be able to choose the product type, so that production level of all those different products we mentioned before, the different band combinations, and then you can choose other opportunities like putting DRA on, AComp, and HD as well. At this point, I would hit order, and within the system in MGP, it would track that order almost like you're ordering pizza, let you know when that deliverable is ready, and you can either download it or have it delivered direct to an S3 or to any other cloud storage. With that, I'm going to hand it over to Ryan Hamilton, who's going to talk to you about our 3D products.
Great, thanks, Josh. Hopefully all of you can hear me okay. My name is Ryan Hamilton. I'm the product manager for the Precision 3D product suite. And I want to take just a brief 10 minutes here today to talk about some of the newest products available through CSDA, our Elevation DSM and DTM products. On the next slide, we've got a little bit of an overview of how these products are made. And so this is a really exciting time to be involved in global elevation data sets. There's been lots of other global elevation data sets that have been produced in the public domain or through other private companies, but nothing that's been produced at a 50 centimeter resolution with a global accuracy of sub 3 meters. And that's exactly what Maxar is doing, leveraging the 125 petabyte image archive that Josh mentioned earlier, and using all those images in a complex process of multi-view 3D reconstruction to build this high resolution, fully immersive, photorealistic 3D for every spot on the surface of the Earth. This has been an ongoing project for Maxar for about 5 years now, and we currently stand at about 95 million square kilometers of this high resolution, high accuracy 3D product. If we cut the video again here, just to run through that, what we're really relying on is the depth of the imagery. So for each pixel, we need overlaps of about 15 to 20 images. So what we're looking at here is the collection of a single production geocell, which is about a 10,000 square kilometer area. And you can see that the images are collected over a multi-temporal span. We're using a depth of about 15 to 20 images to overlap, and we're collecting all those images at a bunch of different view angles. And that's part of the key components, is not just the images themselves, but to make sure that we've got all these different angles that are being represented there in the video so that we can see all sides of these features and truly get measurements. So if you look on the left-hand side of this slide, there's 3 distinct features I want to point out. First is what I just mentioned with the complete measurements, the idea that by having this deep stack of images from all these different look angles, we're eliminating or near eliminating a lot of the occlusion that you would get from other optical collection methodologies. The other part is that we're getting this consistent global high accuracy of sub 3 meters in the spherical error 90 percentile. So 3 meters if you're on the side of a building or on the ground or at the top of a building, that spherical error, which equates to a CE90 and an LE90 of sub 3 meters. We're able to get that because we're taking all those images that you saw during that collection. And as Andrew mentioned, it's some of the highest accuracy satellite imagery available. We're refining it even better by combining it together. So as you combine all those images on a pixel by pixel basis, you basically average out the pointing error that would be native to that satellite image, and getting that consistent global accuracy through this build process without any ground control points. And then the final piece is the high fidelity of the surface representations and the elevation representations. Because we are aligning this deep image stack through this photogrammetric 3D reconstruction process, we're actually doing a pixel by pixel alignment at that 50 centimeter bin size and able to extract the full resolution of those features into our elevation models and 3D products. So we're building the highest resolution, most accurate representation of the entire face of the Earth, enabling customers to see the world at global scale in fully immersive 3D with this 3 meter absolute accuracy and 50 centimeter resolution. In the next slide, we can see what those products actually are. So on the top left there, under the 3D mesh products, that top left product is the 3-dimensional surface model, the 3DSM. And this is the core product that is built through that process that I showed on the previous slide. And like I said, we've built about 95 million square kilometers of this. We build over 3 million square kilometers per month. And we use this core parent product to extract all the other products that you see on this page. And the beauty of that process is that there is perfect co-alignment between all of these 3D and elevation and extracted products. So across the first row, you can see that we also do a 3DTM, meaning a 3-dimensional bare earth model that still has the pixel representations as textures on that terrain model. And then we also do 3D textured objects, which are the buildings and the vegetation represented as mesh with full texturization sitting on a 0 plane. So those are basically all the features that were removed from the surface model to make the terrain model. Now, as I said, we extract these other products from those mesh products. So the elevation products, the DSM, the DTM, and the digital height model are all produced from those surface models. The DSM, the digital surface model, is elevation measurements of all the first return features. So think of the buildings, the vegetation, and where visible, the terrain. The DTM, the digital terrain model, is the bare earth model, where those features have all been removed through automated processes, and we're just representing terrain features. The DHM is the difference between those two models. So it's basically the buildings and the vegetation standing by themselves on a zero plane with their heights. And we also offer a point cloud for customers that are used to LiDAR applications where .las and .laz formats would be useful. And we offer RGB attribution within those point cloud models. So you do get somewhat of a representation like the surface mesh with the textures on that point cloud model. And then on the final row, we have our extracted products. So these are the products that are not elevation products or 3D products, but they're still part of the process. And again, co-registered to all these products. We have the true ortho, which is a nadir top-down view of the 3D model. It's a 2D product, but think of it like an optical image that was captured from straight above all the features. So you see no building lean or occlusion in that model. We also do classification as we build the Precision 3D products. So the actual 3D reconstruction process has to classify each pixel as buildings, vegetation, ground, water, road. We have two different classification schemas, either a standard 8 class or an advanced 28 classification, which is automatically produced as we produce this product. And then from that classification, along with the DHM height information, we can produce simple vector models of the buildings and the vegetation, which are basically outlines of all those features within the classification. They've been sharpened and improved through AI processes, and then heights extracted. So you get very accurate building and vegetation representations around the globe. And that's the beauty of having this global coverage, is all these products that are shown here are available globally and produced automatically during that 3D reconstruction process. The two I want to focus on that are the new products being added to the CSDA are the two blue ones in the middle, the DSM and the DTM. And on the next slide, there's a bit more detail showing those products. Here we see the DSM, again, first surface measurements. We see all the buildings and the vegetation in the scene over Indonesia. We offer this product in multiple resolutions. All the different resolutions are extracted from the native 50 centimeter product that you see here. Through CSDA, what we are offering for now, and we can expand those offerings if there's requests to do so, but we are offering the 1 meter DSM and DTM products. So if we toggle the next one, and we can go back and forth between these two, you can see the DTM product, the digital terrain, where those buildings have been removed. And you can see that perfect alignment between these two products, meaning if there are measurements of surface features that you want to be able to conduct, there is perfect coherence between these products, and you'll get actual measurements of those surface features. So that's a brief overview on the products. I want to just jump into a couple of use cases that are common for these products that we've had other customers using. The first one on this next slide, oh, yes, this is kind of an outline of those use cases, right? So elevation products, understanding just what is the elevation over the area, as well as what's the slope, what's the aspect for hazard assessments and flood models and things like that, being able to really understand what that terrain is to help with the evaluation. 3D terrain, we talk about more detail, the granular buildings, the vegetation, things like wind power farms where you need to understand the turbulence that might be created by the surface. Or signal propagation, any of those evaluations where those surface features are really important. When we talk about mapping and imagery, the mapping piece is a very obvious use of the elevation. We're talking about topographic mapping with contours and features so that we can understand the area of assessment and the terrain. The imagery part being that use of elevation models within orthorectification processes to make sure that you're stretching and compressing the image to account for that elevation piece. And then the final box are features. So as I mentioned in the product overview, we are extracting all these individual surface features. You can use those features for analysis of understanding where population densities might be or counts of population in remote areas, looking at tree counts as well, or timber volumes by looking at not just the count of the trees through the vector features, but the differentiation of the volumes that you can see through the DHM. So on the next slide, one of those use cases I mentioned is flood assessment. So here, which is kind of a relevant slide for what's happening, We can see in this area if there was to be a coastal inundation event. That's, if we click the next button here, we can see how the buildings and the coastal populations are affected by that flood. We toggle back and forth, you can see the differences there, very notable up in the top, that it's not just where the flooding is happening and the depth of that flooding that can be analyzed, but also the buildings that would be affected and how many floors on those buildings would be affected because of the 3D nature of this data. And then I think the next slide is my final slide. I've put together what I think is a relevant video here to kind of show the value of this very high resolution data in remote regions of the world. So as I mentioned before, there are lots of global DEMs out there like SRTM and others, but at 30-meter resolution, you don't get the fidelity and detail that you can get from the Precision 3D elevation products. So if we click play on this one, what we're looking at here is the Baigache crater in northeastern Kazakhstan. It's a really remote region. This crater is about 5 million years old and 8 kilometers across. And it's sort of distorted and it's hard to see, but when you zoom in, you can see the ring of the crater impact zone. And you can notice as we pan across here that the center area, which is relatively flat, has been used for a lot of agricultural use. So it's been plowed and flattened even more. And you can see the subtle differences of the surrounding crater mounds. So the interesting thing about our Precision 3D data here is as we zoom in on these areas, you can actually see those rock outcroppings and rock deposits on these features because we have that level of detail and granularity. And again, this is a product that is consistent like this across the globe. With no GCPs, we're still getting those same accuracies. So hopefully this is something that you find very useful through the CSDA program for your scientific evaluation. And with that, I am going to pass the mic over to Francois.
Hello, thank you, Ryan. I'll be talking about image quality and our ARD product. Next slide. So we try to provide the highest quality possible of surface reflectance imagery. And since all of our sensors are built with very high quality components, we are able to calibrate the imagery to a high precision. The first step to producing high quality image data is the absolute radiometric calibration. So for that, we employ a reflectance-based vicarious calibration approach that's pretty well known. It's used by NASA and ESA and other agencies. This method uses in situ measurements of the surface reflectance. So a spectrometer is looking down at the ground at ground level. And also sensors looking up through the air column to understand atmospheric characteristics. And then that's put into a radiative transfer model to predict at sensor radiance for validation and calibration efforts. And this is done many times. Many measurements over many dates are used in a regression to determine the required adjustments to the pre-launch calibrations. And that's how we establish the calibration coefficients, which are applied to the images and published in the metadata. This process is typically repeated annually, mainly in the summer. Next slide. So how do we get from that calibrated imagery to surface reflectance? Well, first off, what is surface reflectance? Surface reflectance is the physically based normalization of the image values regardless of the different atmospheric and viewing conditions. So it corrects images to be consistent with viewing the area from the ground. So that's what we're trying to get to, is what the reflectance on the ground is. So basically, that's the attempt to remove all the differences scene to scene that can come from the provenance of the satellite bus in orbit, and any atmospheric conditions or contaminants in the air column between the sensor and the ground. It is, well, it's called reflectance because the pixel values are actually a percent, 0 to 100% of the amount of light that is reflected from the ground at each band, which is then multiplied times 10,000 to store as 16-bit integer values. So looking at the schematic, the imagery comes from the sensor. Calibrations are performed. We have digital numbers. And then from there, we do the transform to top of the atmosphere radiance. That accounts for mean atmospheric solar irradiance, the solar zenith angle differences, and differences in the images between Earth-Sun distance. And then from there, where we're trying to get to is the surface reflectance, actually. And that compensates for not only the solar illumination differences, the Rayleigh scattering, but also the atmosphere. And that's really the key. So, and that's actually the more difficult part of this. So we have created ACOMP, which is Maxar's atmospheric compensation. It's created by our own Dr. Fabio Pacifici. ACOMP is Maxar's method for atmospheric compensation, which means that estimating the effects of the atmospheric contaminants for each pixel in each image. The atmospheric contaminants usually primarily include like the aerosols and water vapor, and they have the effect of scattering and absorbing and reflecting and diffusing the light differently in the air column, and differently in the different wavelengths or bands of the image. So as you can see in this image, at the top panel, there's kind of a hazy image, and then a byproduct of ACOMP is this pixel-based aerosol optical depth layer. And most of the atmosphere correction methods, standard methods, have a single coefficient for optical depth, for aerosol optical depth for each image, and ours is a little different because it's pixel-based. This works on the PAN, VNIR, and SWIR imagery. Also, it's fully automated and suitable for large-scale production, which we use it for. Yeah, next slide. Okay, so this slide is just showing the difference between the top of the atmosphere corrected imagery and the surface reflectance, which is also known as bottom of the atmosphere corrected imagery. You can see in the top panel, typically top of the atmosphere corrected imagery looks more hazy, less, there's less contrast. And if you were to create, let's say, like a spectral profiles for various features, you would see that they are sort of compressed or muted in certain bands, like near infrared over vegetation, and then elevated pixel values in like some of the lower band wavelengths, like in the blue band. So, but after the effects of the atmosphere are removed and the imagery, you see that the imagery is clear in the bottom here, and it's a better representation of the amount of solar radiance recorded at each pixel. Yeah, next slide. Finally, I just like to mention that analysis-ready data imagery is available for Maxar. The analysis-ready data, or ARD, is a processed version of the imagery that it's transformed to surface reflectance, geometrically aligned, resampled to the same GSD, snapped to the same grid, mosaicked and tiled, so that is, it's generally usable in a production workflows, so without any additional processing of the input imagery. When you order ARD from MGP, you get three products. They're all cut to 5 kilometer by 5 kilometer tiles, and they include this 16-bit surface reflectance multispectral tiles, a 3-band 8-bit visual tile, and data masks, which include cloud and cloud shadows, a vegetation mask, a usually empty mask of bad data, like in case of band saturation or a data dropout, usable area mask. Also terrain shadow mask and a water mask. Now you can't access the ARD from the MGP UI, but there is a way to access through an API and order it that way. And I don't have time to get into any of that, but I can tell you to go to the website, which is ard.maxar.com, and I'll put that in the chat, I guess, at some point. Okay, next slide. Yeah, okay. So that's our presentation, and over to you, Jennifer.
Okay, thank you so much, Francois. At this point, what I will do is I will open the final optional set of polling questions. And let me jump straight, you should see those now. Let me jump straight into the questions. We've had several that were asked in the chat, so let me start with a couple of those. And actually, if people could, if you haven't already, please try to paste or copy and paste those questions entered into the chat into the Q&A panel. That'll be super duper helpful. All right, so let me just identify the first question here. Takes a bit of scrolling in the chat. All righty. Okay, this may not be the first, but I will hopefully address all of the questions. So the first question is, when will you allow downloading of vivid imagery?
So I can answer that, but I'll defer to Dana since it's not a product that's available through for download through EOCL or EGD, where some of the other traditional 2D products are. So that is not currently available. But Dana, I'll defer to you on how that could be made available.
Yeah, so I'll just elaborate a little bit more. The way that the CSDA program works is our vendors like Maxar will propose a product suite to us as we evaluate it and bring it into an on-ramp process, then we can make that data available. But because we have contractual limitations, that has to be a process that's done through like a solicitation, although we are looking at alternatives into bringing in data into the program a little bit more efficiently in the near future as we start to evaluate some of that procurement process.
Okay, thank you so much, Dana, and thanks also, Andrew. So as a follow-on to that initial question I just asked, are the vivid maps like peak greenness, or do they also include winter images as well?
Yeah, I can take a shot at this one, and then if my colleagues want to back me up, we typically include imagery during optimal seasonal light conditions. So peak greenness would be included. We try and not include any snow or winter imagery in these vivid base maps. But there's areas, where there's perpetual snow glaciers, where you will see some snow.
Okay, thanks so much, Andrew. All right, moving on to the next question. Is the data only available for NASA-funded researchers?
So I can take this one. So right now, and I put this detail a little bit in the chat because it's lengthy and dependent on the data you want to access. We basically have, with the Maxar data suite offered through the CSDA program, 4 associated EULAs, and it just depends on which product that you are accessing. So for Maxar, there's a Maxar specific EULA for Worldview 4 imagery that is specific to NASA funded programs. Data acquired by CSDA through the IDIQ contract for Maxar data is under the CSDA USG license, which covers all US government entities, state and local governments, territories, and tribal authorities within the US, non-governmental organizations like NGOs, nonprofit organizations that work for the purpose of the US, contractors, et cetera, that are all funded by the US government. And then NRO has a commercial data imagery end user license agreement fact sheet that covers all Maxar imagery except Worldview 4 and IGNOS, which has a license similar to CSDA that covers all the US government. And then the NextView imagery license for IGNOS imagery is also similar to the USDA with the availability to all US government. I hope I have that right, but anyone can correct me if I'm wrong, please, with Maxar. But it's complicated because we do have 4 EULAs, and you can see those associated in the CSDA table, or when you go to get authorization for access to the data.
Okay, thank you so much, Dana. So the next question is, will the MGP replace or augment GEGD?
Yeah, I can take this one. MGP will become the platform that serves global EGD. So the current global EGD application is based on our SecureWatch platform. It will be replaced by what we call Global EGD Pro, and that will likely happen Q1, maybe late March, early April of 2025. And that's going currently under all the proper checks and authorities through NGA to get that approved.
Okay, well, thanks so much, Josh. That was perfect because there was a follow-on question regarding the timing for this replacement. So the next question, I'm moving on to the next here. Can you comment on the frequency of global background tasking from the Maxar constellation for P3D and vivid refresh frequency?
I can jump in with the Precision 3D. So we are doing what is referred to as archive harvesting for the production of the Precision 3D product, meaning that we're utilizing that imagery that's available through the archive. The algorithm does rely on the most recent imagery to give the 3D reconstruction geometries and textures. So the deep image stack has 2 purposes. One is to set that accuracy alignment, meaning the bundle block that we do with all those images gives us the positional and height references we need to have an accurate product, while the most recent imagery is actually used for the texture and 3D reconstruction piece. We do, however, when querying orders or areas of interest, look at that vintage component as sort of a median date of the image stack to determine if it is older data and maybe need a refresh. And we will do a refresh based on available imagery, but we're not, for most cases, actively tasking for the Precision 3D product. It is a product that is built on spec at a global basis with a regular cadence of refresh based on older areas of 3D build blocks.
Perfect. Thanks so much, Ryan. The next question is there information available for the base maps when the particular area was taken that is being used to generate this portion of the map?
Can I? Oh,
Please, no, Francois, please, Dr. Francois Smith, please, by all
let's
means.
get out of here. Anyway, I know that there is the mosaics are built. There is a layer that's produced. It's a vector layer in which all the metadata I'm sorry, all the metadata exists in these shape files, and they also show the seam lines for all the component scenes for each of the mosaics, the cut lines that are showing the exact shape. So every pixel can be tracked, what date of imagery it came from, and also what collection parameters exist for that pixel, and some other information too. So yes, everything's traceable.
Okay, thank you so much, Francois. So the next question is, do you have tools for online vector editing so we don't need to download all of the raster data?
The short answer, and I'll lean in at the risk of getting in trouble with anyone else on the call. The short answer is not really. The easier answer is there's a way that you could stream the imagery in to any of your vector editing solutions, whether it be ARC or QGIS, or whether it be an online platform. It's something that we're considering and exploring, but right now there is no dedicated vector editing solution through Maxar.
Well, thank you so much, Josh. The next question is, are the 3D products also available in equatorial areas? If so, what's the frequency?
So the answer is sort of. We have a lot of the equator covered with the Precision 3D products, but there are still cloud belt areas, the DRC and some areas around Colombia and in Indonesia, that we have persistent clouds that getting to that 15 to 20 image stack required for the 3D reconstruction is tricky. We are proactively tasking those areas, and with the introduction of Legion, especially with Legion 3 and 4 in the Mayo, the mid-inclination orbits, that could give us some more collection windows where some of those cloud conditions are lessened. But the short answer for that is that we do have an online construct visible through the MGP application where that data is available. And I think it will be visible as well through Satellite Data Explorer, SDX, to see where that data is available so that you can see if it's there, and if not, put a request in for the build to happen and it can be built through a feasibility check.
Okay, excellent. Thank you, Ryan. The next question is, would Maxar consider improving the data delivery process? Specifically, the delivery time could be shortened to approximately 1 week, or even better, the data could be downloaded directly like some other commercial data at CSDA. No real-time or near real-time data are needed here. Thank you.
Depending on which data product you're downloading, it should be less than a week, especially using MGP. For example, the image that I showed in that video, that downloaded in, I think, under 90 minutes. So depending on the size and the scope of what you're downloading, it should be less than a week, hopefully. And in terms of delivery, you should be able to download it directly or have it again sent to an S3 or other cloud location.
And on the Precision 3D side, same ease of access in that the data, as I mentioned, we've got about 95 million to 98 million square kilometers of data off the shelf ready for download. We have streaming services through the MGP. That video I showed was a streaming that I also downloaded the data, and the download for a few thousand square kilometers was about 3 hours.
Yeah, so I just want to clarify one thing here. So, and Dana, you may want to jump in, but we have the physical means to deliver the data that's available in the archive very quickly. If you're tasking imagery, then that has to go through different channels through NGA, coordinated with the CSDA program. So it just depends on what type of product you're asking for, and if that's available through NGA, then has to be passed back through the CSDA program. That may create a little lag. We'd love to learn how we can better support faster delivery, working with NGA and CSDA. But Dana, any other comments you want to make on that?
Yes, absolutely. I agree with you, Andrew. Part of our hiccup is that pipeline process, and it's not the Maxar delivery itself. It's more of the pipeline from CSDA accessing data through the appropriate licensing agreements and utilizing NGA as the source. The data that we will be acquiring directly through CSDA is a lot more accessible once we do actually get it into our cloud framework and make it available. So we are working on making some of these pipelines more efficient, both with Maxar and with our government partners. And so hopefully that will improve over time, and you'll see more quicker access rates.
Okay, so thanks to all of the Maxar panelists as well as Dana with the response to that question. So the next question is the derived aerosol optical depth data very high resolution?
Yeah, I'll take that. The AOD layer is a byproduct of the ACOMP process. It is at the same resolution as the multispectral bands, but we don't offer that as a product or anything. That's just used in the processing.
Okay, thank you, Francois. And at this point, I'm just taking a scroll through the chat to make sure I didn't miss any questions that were posed there, and then I'll hop back down to the Q&A. And let's see if I've addressed all of them. Thanks for bearing with me. Again, just as a reminder, today's event has been recorded, and what we will do is I will send a link to the recording as well as to the presentation slide decks to all registrants and participants. So if you have any colleagues who registered but were unable to attend, they will still be able to access this content at their own leisure, and this content will be uploaded to the Commercial SmallSat Data Acquisition Programs playlist within our NASA Earth Data YouTube channel. All right, so I don't see that I've missed anything in the chat. Okay, yes, I do see one. Have you validated the data recovered from AOD, and have you written any papers about this product?
I personally haven't, but the person who created this process, Fabio Pacifici, has authored numerous articles, and I can put references to that into the chat, I suppose. So, yeah.
I think that would be great. Thank you. I would appreciate that. It'd be a helpful reference for everybody after the fact here. Okay, so let me see. I think we addressed yes, okay, so there's a second for that. Another data user or researcher is asking to see some of the studies. Okay, perfect. And then I think we've addressed the delivery time frame. There was a second question on the same topic. Let me hop back down to the Q&A. Let's see if I think we've tackled those as well. Thanks for bearing with me here and your patience. Give me one moment. All right, let me look over. All right, I am not seeing any additional questions. So if there are no additional questions, we do have about 9 minutes left in the extended Q&A period, but I'll give it a minute or two here. But if not, the way that this will work is that we will log off from the audio component, and we will leave the virtual meeting space opened an additional 10 minutes from. Right. So,
Jennifer, I think David at 12:45 had a question for Ryan that I don't think we addressed.
Okay, let me take a look in the chat.
In the Q&A.
In the Q&A. There's also, I mean, maybe if you could explain again, because we did talk about the delivery time frame and why it varies, but if you could reiterate why the delivery time frame of some products is in weeks, that would be helpful. And then I'll get to the question that's assigned for Ryan.
Okay. Yeah, I mean,
Thank you.
So as Dana mentioned, it depends on what type of product that you are ordering. So if it's available in the Maxar archive or the NGA archive and the CSDA archive, it can be very fast. If it's a tasking order, a new collection, new acquisition, then that does need to be coordinated through NGA with the CSDA team leads, and that can take some time. So it just depends on what product you are ordering.
Okay, thank you. And I did miss a question. My apologies. I'm just trying to, jump between the two. So the next question is there a plan to release the 50 centimeter DTM data?
Andrew, do you want to address that as part of the CSDA program?
Yeah, I can address that. So we did include 1 meter resolution. 50 centimeter is available. We can work with Dana and team to understand the needs and requirements within the program and consider adding that to the list.
Okay, perfect. Thank you. And then there is another question here. If I heard you correctly, Maxar does not plan collection to update your does not plan to update your Vivid layer collection, but instead leverage customer-tasked AOIs for updating the Vivid layer. How can I get a complete metadata file for the 2024 Vivid updates over Alaska so that I can review and compare to previous years in government-acquired mosaics?
Yeah, I can start that one, but Josh or Francois, if you want to help me finish it. So the refresh spec for Vivid is 40% refresh every year on a global basis. So it varies in areas of the world. We're dealing with, the entire world, but that is 40% is the refresh spec. And so we refresh, the world basically every 2 years, and a little bit more with our Vivid program. As Francois mentioned, we can provide shapefiles of the Vivid builds with metadata that includes acquisition date and any other information that resides in the metadata, including seam lines, things like that. So we should be able to provide that to you, Chris.
Okay, thank you very much. And let's see, I've got another question here. Okay, another question. You mentioned that the data can be delivered directly to cloud storage. Is it possible to have data delivered to cloud providers other than Amazon, for example, Google or Microsoft?
Yes, is the short answer. We do provide to Google. I'd have to go back and double check if we also provide that to Microsoft as well. I'm just skipping ahead in the video to look very quickly. So it does appear that we provide to S3, Google, and Azure Cloud along with an SFTP or FTP location.
Okay, thank you so much. Oh, I apologize. Go
Sorry,
ahead,
Jennifer.
Dina.
I just want to elaborate on that too. So it depends too on where you're getting the data access through. So if it is through the CSDA program or one of the government entities, we do use the AWS Cloud Framework, and that's where we currently have our storage of the data. So you can certainly pull from AWS into another environment. We are looking at some other types of program models, not leveraging other platforms only for kind of analysis tools and services, but not with direct storage. So right now it's currently only through AWS for the CSDA program.
Okay, thank you, Dana. Thanks, everybody. So the question for Ryan, can Ryan provide more details on the P3D DTM processing workflow and previous QA/QC efforts? I believe the 3-meter absolute, 1-meter relative accuracy only applies to the DSM products, not corresponding DTM products. We might need to break this up. It's quite lengthy. Under dense canopy in urban areas requiring significant interpolation. And although the DTM is posted at 0.5 meter GSD, what is the true resolution under canopy? So let me know if you want me to reread.
No, I got it. Yep.
Perfect.
Yeah.
Excellent.
Thanks, David. Great question. So yes, the 3-meter specification that has been validated for the absolute accuracy with the 1-meter relative through both high resolution photogrammetric data sets around the globe, as well as many GCPs and control points and multiple independent accuracy studies, is for the 3DSM product. So the derivatives coming off that 3DSM product, like the raster DSM, obviously maintains those exact same accuracies. While the DTM, because it does have to be modified to get the bare earth terrain, is a bit variable. So the specification for the 3-meter absolute, 1-meter relative applies to the DTM in open barren areas, basically where it is equating to the DSM. While under forest canopy and dense urban areas where you're going to have to remove those surface features and interpolate, we've actually built some smarts into the DTM editing algorithm process. So it does understand undulations of tree canopy and looks for basically terrain clues for how that terrain should be, but it is still an interpolation process that's happening at the core. So those accuracies under dense canopy become best effort at that point. the same as with the buildings, we're relying on all those ground identifications in either forest or building areas to try and do the best interpolation we can, along with clues from the surrounding terrain. But it's going to have to be a best effort accuracy in those spots. To your point about the GSD, yes, the mesh equivalent is a 50 centimeter equivalent when it starts, but once it gets edited down, it gets thinned. Analysis on this has put it more at the equivalent of about 2 meters once that editing happens. So still a high resolution product, but not like a LiDAR DTM where you're actually getting penetration through a tree canopy and getting those multiple return points. This is an optical product, so it relies on what can be seen through the satellite view. Hopefully that answers the question on that.
Okay, thank you. We are going to take one final question here. I don't think this has been addressed. If I ask this question, please, correct me. Do you make an aerosol correction? If so, how?
Yeah, I guess that's me. Yes, that is one of the major features of ACOMP. It does make an aerosol correction, and it's done at the pixel level, which is what distinguishes it from other atmospheric condensation algorithms. And that, yeah, you have a pixel-based aerosol depth layer, and that is incorporated into the surface reflectance output.
Okay, well, thank you very much, Francois, and thanks to all of our Maxar speakers and to Dana Ostrenga from the CSDA program for your content this afternoon, and thanks to all of you for joining us and taking the time out of your day for this webinar event. So at this point, we will log off from the audio component, and I will leave the virtual meeting space open. If you have any additional questions or feedback that you would like to share with our panelists from Maxar or with the CSDA program. If I did not get to a question in the chat or the Q&A, please know that is not intentional, and your panelists will be able to follow up with you offline. So thanks to all of you for your time this afternoon. Thanks to all of our speakers, and thanks also to Dana Ostrenga. And with that, we hope to see you at an upcoming event. All right, thanks so much, everybody. Okay, goodbye now.